Good evening. Actually, this sum was given for homework, but let us discuss the solution. Find the number of ways so that letters of the word history can be arranged as Y and T are together. Second, Y is next to T. There is no restriction. Begin and end with vowel, end in ST, and begin with S and end with T. Now, in the word history, the number of letters is 7. First part, words in which Y and T are together. Since Y and T are always together, consider them as a single unit. Now we have 1 plus 5 equal to 6 different letters that can be arranged in how many ways? 6p, 6 ways. After this, Y and T can be arranged among themselves in 2p, 2 ways. Hence, the total number of words, actually they should use the word arrangement, because by word we mean an arrangement which has dictionary meaning usually. So they should say arrangements. Anyway, total number of words formed in which Y and T are together, always together, is 6p6 into 2p2, that is 1440. Words in which Y is next to T. Since Y is next to T, consider TY as single unit, where their position is fixed. Come on, THEIR, it should be. So we have 1 plus 5 equal to 6 different letters that can be arranged in how many ways? 6p, 6 ways. Now don't say that Y and T can be arranged in 2 ways. No. What is the condition? That Y is always next to T. So we don't want YT, we want TY only. So number of ways is 6 factorial, that is 720. Words in which there is no restriction. There is no restriction. 7 distinct letters can be arranged among themselves in 7p7, that is 7 factorial, equal to what? 5040 ways. Actually, this was given for homework. Words begin and end with a vowel. I and O are 2 vowels and 2 positions are fixed for this. So the remaining 5 positions are left for 5 consonants. The 2 vowels can be arranged at these 2 positions in how many ways? 2p, 2 ways. So number of ways is 2p2 into 5p5, that is 2 into 120, that is 240. Words end in ST. Since the words end in ST, we have to arrange remaining 5 letters. This can be done in 5 factorial, that is 120 ways. Words begin with S and end with T. So first and last are fixed. So remaining 5 are to be arranged. This can be done in how many ways? 5p5, that is 5 factorial, equal to 120 ways. Sum number 12. Find the numbers of 6 digits using digits 3, 4, 5, 6, 7, 8 without repetition. How many of these numbers are? First part divisible by 5, second part not divisible by 5. Now just subtract first part from total number, you get second number. Write down. We are given, write the solution. We are given 6 different digits, 6 different non-zero digits. We are given 6 different non-zero digits as repetition is not allowed. As repetition is not allowed. As repetition, REPETITION, as repetition is not allowed. 6p6 equal to 6 factorial. 6p6 equal to 6 factorial equal to 720 numbers of 6 digits can be formed. 720 numbers of 6 digits can be formed. Okay, next line, A, first part. Number formed is divisible by 5. Number formed is divisible by 5. Number formed is divisible by 5 if units place digit is 5. If units place digit is 5, therefore remaining 5 places, therefore remaining 5 places can be filled using 5 digits, in 5p5 equal to 5 factorial equal to 120 ways. Therefore, required number equal to 120. Required number equal to 120. Next line, B part, B. Out of 720 numbers, out of 720 numbers, 120 are divisible by 5. Out of 720 numbers, 120 are divisible by 5. Therefore, remaining, that is 720 minus 120 equal to 600 are not divisible by 5. Sum number 13. A code word is formed by 2 different English letters followed by 2 non-zero distinct digits. See, followed by means strictly 2 English alphabets first and then 2-digit numbers, rather 2 digits. Find the number of such code words. Also find the number of such code words that end with an even digit. Right down. There are 26 alphabets, English alphabets. There are 26 English alphabets, of which 2 can be arranged, in 26 P2 ways. In 26 P2 ways. Full stop. There are 9 non-zero digits. There are 9 non-zero digits, of which 2 can be arranged, in 9 P2 ways. In 9 P2 ways. Therefore, total number of code words available equal to total number of code words available equal to find out 26p2 into 9p2. So 26 factorial upon 24 factorial, 9 factorial, 7 factorial. So this is basically 25 into 26 into 8 into 9. Tell me the answer. Type your answer in chat box. Okay, one student has written 46,800. Yes, correct. Please do not use calculator. Now, second part. Code word is to end with an even digit. Code word is to end with an even digit. Therefore, this can be arranged in 4 ways. This can be arranged in 4 ways. Why 4? Because 2, 4, 6, 8. From 1 to 9, out of these 9, 2, 4, 6, 8. These 4 digits are even. Okay. So this can be arranged in 4 ways. Other digit is to be selected from remaining 8. Other digit is to be selected from the remaining 8. Also, 2 alphabets can be arranged in 26p2 ways. Also, 2 alphabets can be arranged in 26p2 ways. 26p2 ways. Therefore, total number of code words ending with an even digit equal to 26p2 into 4 into 8. Now 26p2 is 26 factorial upon 24 factorial into 4 into 8. So 25 into 26 into 4 into 8. Type your answer in chat box. 20800. Is this correct? Yes, it is. Sum number 14. Find the number of ways in which 5 letters can be posted in 3 post boxes if any number of letters can be posted in the post box. Okay. Write down the solution. 5 letters to be posted in 3 post boxes. Write down. 5 letters to be posted in 3 post boxes. as any number of letters can be posted as any number of letters can be posted in a post box as any number of letters can be posted in a post box. Each of the 5 letters can be posted. Each of the 5 letters can be posted in 3 ways. In 3 ways. Therefore, total number of ways equal to 3 into 3 into 3 into 3 into 3 equal to 243. Sum number 15. Find the number of arranging 11 distinct objects taken 4 at a time so that a specified object A always occurs, B never occurs. Let me explain the solution and then we'll write. In first part, one particular thing always occurs. Means we have to arrange remaining 3, but out of 10. So it can be done in how many ways? 10p3 ways. But that particular object can be at first position or second position or third position or fourth position, right? So finally it is 4 into 10p3. In part B, they say one particular thing never occurs. So 3 are to be arranged, but not from 11, from 10. So this can be done in how many ways? 10 P3 ways. Okay, right. A, specified object always occurs. A, small a in that item, specified object always occurs. In that item, so remaining 3 out of 10 can be arranged. Remaining 3 out of 10 can be arranged in 10p3 ways. In 10p3 ways. Also, specified object can be at any one of the 4 positions. Specified object can be at any one of the 4 positions. Therefore, it can be arranged in 4 ways. It can be arranged in 4 ways. Therefore, total number of required arrangements equal to 10p3 into 4. Total number of required arrangements equal to 10p3 into 4. So find out. 7 factorial gets cancelled. 8 into 9 into 10 into 4. So 2880. B part. Specified object never occurs. Specified object never occurs. Therefore, four objects are to be arranged. Four objects are to be arranged from the remaining 10 objects. From the remaining 10 objects. Therefore, number of ways equal to 10p4. 10 factorial upon 6 factorial. Tell me the value after cancelling 6 factorial. 7, 8, 9, 10. Which is actually 7 factorial 5040. Sum number 16. Let me explain, but please do write the solution after the lecture. In how many ways can 5 different books be arranged on the shelf if there are no restrictions? 2 books are always together, 2 books are never together. Now, when there is no restriction, 5 books can be arranged in how many ways? 5 that is 5 factorial, that is 120 ways. Now we have to arrange 5 books in which 2 books are always together. Now these 2 books can be arranged among themselves in 2p2, that is 2 ways, considering these 2 books as a single unit. So that and remaining 3, that is 4, can be arranged in 4p4 ways. So total number of arrangements in which 2 books are always together, by that they mean 2 particular books. 2p2 into 4p4 comes out to be 48. Now out of 120 arrangements, in 48 arrangements, 2 particular books are always together. So in remaining, they are never together. So 120 minus 48. Okay, that is 72. But here they have used different method. 2 books are never together. We can arrange these 2 books at 4 places. 2 places in between remaining 3 and 2 at the ends. So in 4p2 ways. After this, the remaining 3 books can be arranged in 3p3 ways. Right? Logic is different, but of course answer must be the same. 17th, 3 boys and 3 girls are to sit in a row. How many ways can this be done if? First part, there are no restrictions. Second, there is a girl at each end. Third, boys and girls are at alternate places. Fourth, all boys sit together. First part, there are no restrictions. Now, number of persons or students, 3 plus 3, 6. Now, there is no restriction. 6 persons can be arranged in how many ways? 6p6, 6 factorial, that is 720 ways. So, answer for the first part, 720. Now, second part is what? There is a girl at each end. Now, the 2 ends are to be occupied by 2 girls, but number of girls is 3. So, this can be done in how many ways? Repeat 2 ways. Okay. Now, remaining 4 persons, that is 1 girl and 3 boys. 4 persons can be arranged among themselves in how many ways? 4p4 equal to 4 factorial ways. Nowadays, 3p2, it is nothing but 6. So 6 into 4 factorial, 24, which is nothing but 144. This is second part. Third part, boys and girls are at alternate places. Now, 3 boys and 3 girls. Number of girls is the same as number of boys, right? So we can say that how many positions? 6. 1, 2, 3, 4, 5, 6. So boy, girl, boy, girl, boy, girl, or girl, boy, girl, boy, girl, boy. So what I will say is 3 girls can be arranged at 3 positions in 3 factorial ways. 3 boys at 3 positions in 3 factorial ways. Now there are 2 possibilities. Arrangement begins with boy. Second possibility, arrangement begins with girl. So just multiply this by 2. So 2 into 3 factorial, which is 6. So 2 into 6 into 6, which is nothing but 72. So answer is 72. Fourth one, all boys sit together, considering 3 boys as a single unit. So that unit and 3 girls. So 4 persons can be arranged in 4p4 equal to 4 factorial equal to 24 ways. Okay. Now, yes. After that, 3 boys can be arranged among themselves in how many ways? 3p3, that is 3 factorial equal to 6 ways. So total number of arrangements 24 into 6, that is 144. Now the next interesting part is permutations of n things, not all different, but taken all at a time. The number of distinct permutations of n things taken all at a time when p of them are similar and of one type, q of them are similar and of another type, r of them are similar and of a third type, and the rest are all different is given by n factorial upon p factorial into q factorial into r factorial. I'll explain the logic. If I ask you to find total number of arrangements of the letters of the word ERR, I hope you know the meaning of this. To err is human and forgive divine. So will you say that there are 3 letters, so they can be arranged in 3p3, that is 3 factorial equal to 6 ways? No. Why? Because these 2 are not distinct. They are the same. So these 2 arrangements, 2 factorial arrangements are the same. They are not distinct. Okay. And therefore they say that if out of n objects, p things are similar and are of the first type, q things are similar and are of the second type, r things are similar and are of the third type, and the rest are all different, then number of arrangements is what? Is n factorial upon p factorial into q factorial into r factorial. So as per this formula, total number of arrangements of the letters of the word will be 3 factorial upon 2 factorial. Okay. So what is 3 factorial? 6. And what is 2 factorial? It is nothing but 2. So how many? 3 possibilities. Okay. We'll consider another word, say poor. P-O-O-R. How many letters? 4. O occurs twice. So divide 4 factorial by 2 factorial. Now, why this formula? I'll tell you the logic. We say out of n things, p things are similar and are not and are of the first type. Assume that p things are not similar, they are distinct. So those p things can be arranged in how many ways? P factorial ways. Actually, q things are similar and are of the second type, but assume that they are not same, they are distinct. So those q things can be arranged in how many ways? Q factorial ways, right? Assume that r things are not similar, they are altogether different. So those r things can be arranged in how many ways? R factorial ways. And suppose initial number of arrangements is x. So in the process, total number of arrangements is x into p factorial into q factorial into r factorial. But note that in this case, we have said that those n things are all distinct and are taken all at a time. So n distinct things can be arranged among themselves in how many ways? Npn, that is n factorial ways. but required number of arrangements is x. So x is n factorial upon p factorial into q factorial into r factorial. I'll repeat this logic. What is our aim? Our aim is to find total number of arrangements of n things taken all at a time, but p things are similar and are of the first type. Q things are similar and are of the second type. R things are similar and are of the third type, and the rest are all different. Suppose required number of arrangements is x. Now we say, let us assume that p things are not similar, they are distinct. So those p things can be arranged in p factorial ways. Q things are not same, they are different. So those q things can be arranged among themselves in q factorial ways. And we assume that r things are not similar, they are all different. So they can be arranged in how many ways? R factorial ways. So this is possible for each of these x arrangements. So total number of arrangements is x into p factorial into q factorial into r factorial. But in the process, we have considered that n things are all distinct. So n distinct things can be arranged amongst themselves in npn, that is n factorial ways. So we equate, but Rm is x, to find x. So rearrange the terms to get x equal to n factorial upon p factorial into q factorial into r factorial. Just write down this formula. The number of distinct permutations of n things taken all at a time when p of them are similar and of one type, q of them are similar and of another type, r of them are similar and of the third type, and the rest are all different, is given by n factorial upon p factorial into q factorial into r factorial. Exercise 3.4, first question. Find the number of permutations of letters in each of the following words. First word is Divya or Divya, whatever. Write down. But here repetition, not a single word is repeated. Okay, they haven't said that with repetition, no problem. Write down. First one. There are 5 distinct letters in the word Divya. There are 5 distinct letters in the word Divya. Therefore, number of permutations equal to 5p5 equal to 5 factorial equal to 120. Second, there are 9 letters in the word Shantaram. There are 9 letters in the word Shantaram, which include, there are 9 letters in the word Shantaram, which include A thrice, capital A, which include A thrice. And the rest are all different. And the rest are all different. Therefore, number of distinct permutations equal to number of distinct permutations equal to number of distinct permutations equal to Yes, find the value. 9 factorial upon 3 factorial. So once 3 factorial gets cancelled, 4 into 5 into 6 into 7 into 8 into 9. Find the answer. One student has written answer as 60480. Let's check this. Third one. There are 9 letters in the word represent. There are 9 letters in the word represent, which include R, capital R twice, which include R twice, comma, E, capital E thrice, and the rest are all different, and the rest are all different. Therefore, number of distinct permutations. Therefore, number of distinct permutations equal to 9 factorial upon 2 factorial, 3 factorial. So I'll cancel 3 factorial. 4, 5, 6, 7, 8, 9 divided by just 2 factorial, which is 2. Find out. See, you should try to find this answer on your own. Please do not use calculator. So 30,240. Okay. Next. There are 7 distinct letters in the word combine. There are 7 distinct letters in the word combine. Therefore, number of ways equal to 7p7 equal to 7 factorial equal to 5040. Now, which is the next word? Balabharati. 3, 5, 7, 10. Fifth one, there are 10 letters in the word Balabharati. There are 10 letters in the word Balbharati. Which include B, capital B twice, comma, A, capital A thrice, and the rest are all distinct. and the rest are all distinct. Therefore, number of arrangements equal to number of arrangements equal to 10 factorial upon 2 factorial into 3 factorial. So 4, 5, 6, 7, 8, 9, 10, and here 2. I think in the previous sum, in sum number 3, we have obtained 4, 5, 6, 7, 8, 9 upon 2. So 30240 multiplied by 10. So 30240. So 3,02,400. Second sum. You have 2 identical books on English, 3 identical books on Hindi, and 4 identical books on mathematics. Find the number of distinct ways of arranging them on a shelf. Simple. In all, there are how many? 9 books, which include 2 identical English, 3 identical Hindi, and 4 identical mathematics books. So number of ways, 9 factorial upon 2 factorial into 3 factorial into 4 factorial. Right. In all there are 2 plus 3 plus 4 equal to 9 books. Which include 2 identical English books, 3 identical Hindi books, and 4 identical maths books. Therefore, number of distinct arrangements equal to 9 factorial upon 2 factorial into 3 factorial into 4 factorial. See, after cancelling 4 factorial, in the numerator what remains? 5, 7, 5, 6, 7, 8, 9. 2 factorial is 2, 3 factorial is 6. Now 6 gets cancelled and so on. So you get 1260. So how many ways of arrangements? 1260. So that's it for today.